Hello everyone, welcome to this webinar. Before we begin, just message me in the chat box whether you are able to hear my voice clearly and also whether you are able to see the title slide of the webinar. If anyone can just confirm me in the chat box, that will be great. Again, I request all participants to please put the mic from their side on mute so that the voice coming from your side does not disturb other participants. Thank you. So let us begin this particular session. This webinar is titled Next Step in CFD, which is an introduction to CFD software STAR-CCM. So this is the webinar in order to introduce you to the software STAR-CCM+, which is a product of CD Adapco. The roadmap for this session is going to be first few slides on welcome introduction, then the webinar presentation will follow. After that we will take questions and we'll have closing of this particular session. So before we begin, I would like to thank all of you for your registration and for attending this particular webinar. This is an introductory webinar on CFD modeling using STAR-CCM+. So it will try to introduce you to the software, try to highlight some of the features, try to give you applications of the software, and if anybody is interested, there are further information that is available with us, which you can obtain by sending us an email. This is the 9th webinar in a series of webinars that will be conducted by LearnCAX, and we will continue to conduct many more free webinars in future as well. This webinar is designed to act as an introduction to STAR-CCM+ software. So before we begin the technical slides, a brief information about who we are. We, that is LearnCAX, we are an initiative of training division at CC Tech, that is Center for Computational Technologies, Pune, which is situated in Pune, India. We have industry focused courses for CAD and CFD, and our model, which is totally based on online training. That particular model helps participants to learn complex technologies with ease at the time and place of their choice. So we just deliver technology training online at any location just through internet. So now we will go into technical content of this particular webinar. First, this is an overview of what will follow in the coming 20 minutes to half an hour. First we'll see what is CFD. Then we'll see different stages when we decide to conduct CFD analysis. What are the different stages? This is for any participants who are new to the concept of CFD or who are new to the field of CFD. And after introducing participants to the to what is the meaning of CFD, we'll go and jump into the software side of this particular webinar, which is we will introduce you to the software STAR-CCM+, the features of STAR-CCM+, the highlights of this particular software. We will also introduce you to some of the simulation images of this particular of the applications of this particular software, and in the end we will introduce you to the course that we have just launched. This particular course, which is a training course based on STAR-CCM+, we will give you highlights of this particular course. I will also show you a demonstration in between, which is a recorded demonstration in order to show you the workflow when we decide to use STAR-CCM+ software for CFD analysis. So why we are doing all this? We are doing all this to basically study fluid mechanics or fluid dynamics, and there are various methods to study fluid dynamics. The experimental method is there, the analytical method is there, and the computational method is there. So we form part of the computational community or the computational resources. We use computers in order to come up with virtual designs or virtual simulations. CFD is nothing but a tool which provides qualitative and quantitative prediction of fluid flow by means of using mathematical modeling, numerical methods, and software tools. This all combined together produces a virtual simulation of a physics phenomenon or fluid dynamics phenomenon, and it is defined as a science of predicting fluid flow, heat transfer, mass transfer, chemical reactions, and related phenomena by solving the mathematical equations which govern these processes, and we solve them using numerical methods, that is on a computer. So what are the steps involved in a CFD process? First, we build a geometry of the actual problem or actual equipment or process. After that, we divide this geometry into cells or mesh. Then we define physical boundary conditions, such as we allow the flow to come in, go out. We define thermal conditions like temperatures of surfaces, etc. Then we compute. Basically, the computer makes the data crunching, but we say that it's a compute process or solver process. And whatever data is generated, we try to make sense of it by visualizing the data and extracting design related parameters out of that data. So this is the entire CFD process flow. And this can be divided into three main sections. First is the pre-processing, in which there is geometry creation, geometry cleanup, mesh generation, and boundary conditions. The middle section is on solvers, where we actually do the data crunching or data calculations by using different numerical computation techniques. And lastly, we extract the results out of the computer generated data, and this is known as post-processing, where we generate data like contours, plots, the average values of different parameters, and we generate CFD reports out of that. So these are the three main sections of any CFD process. Now let us go into a bit of in-depth of this particular process. Why we are doing all this? We are doing all this to study the physics. Physics may be fluid flow, heat transfer, phase change, solid mechanics, and many more. Instead of going through experimental analysis, we are doing this by mathematical equations, and we are not solving any all these equations by analytical solution. We are actually solving these equations by numerical solutions or numerical techniques by using different algorithms like finite difference, finite element, and finite volume. So this is what goes on inside the CFD process for anyone who is new to CFD. After understanding the background of CFD, let us get introduced to the software for which we are doing this particular webinar, that is STAR-CCM+. STAR-CCM+ is a very powerful all-in-one CFD tool from CD Arabco. Some of the important features of this is, or for which it is well known, is the ease of use. It is all-in-one package. It has automatic meshing, extensive modeling capabilities, and powerful post-processing. It has been developed since 2004, and it uses the latest numerics and software technologies, and it is designed since beginning to handle very large models, above 10 million, above 100 million cells. And it is a complete process integration, which means you have to follow CAD to CAE or CAD to results in one single package. The STAR-CCM tool contains, or the STAR-CCM software contains tools for CAD creation to post-processing. So all is there in a single environment, easy to use environment, interactive environment. We don't need to shuffle from software to software. And as shown here, starting from CAD, the model tree builds up, we go into meshing, the model tree populates, and finally we have the results, everything in a single environment. The last part of the name, that is CCM, is derived from computational continuum mechanics, and the software is based on multi-physics, that is continuum based modeling. The models define which are defined for fluid or solid continua, and there are various regions of the solution domain which are assigned to these continua. The software basically keeps a separation between physics and mesh, and in terms of simulation setup, the mesh is used only to define the topology of the problem. And there are generalized interfaces connecting different domains, and the topological construction order allows communication between different regions independent of the mesh. It has a phase-based solver, and any type of cell type is supported, and there is a fully interactive control over simulation process. It also allows the users to watch the solution develop as the analysis is running and modify settings live. So there is a sort of interactive nature or on-the-go nature to the software. Some of the important features are its ease of use. It can handle the entire engineering process involving fluids and solids, heat transfer, and stress. And it can also perform interactive design studies with minimal user interaction. There are a lot of automated stuff that is happening within the software which we can take use of, and it is highly easy to use, maybe compared to some of the other competitors of it. The licensing scheme is one of the best thing because it provides power on demand and power session licenses, the key which you can use on multiple processors and multiple machines. It does not restrict the user to a single machine. It is like on the go, or sort of a very near about licensing scheme to cloud computing or cloud licensing. It has a complete workflow within a single environment. For example, we can start from importing or creating CAD geometries. There is a powerful meshing tools and physics capabilities which start from steady, unsteady, harmonic balance, conjugate heat transfer, radiation, laminar, turbulent flows, and many more complex physics can be done within a single environment. There is dynamic data transfer and effective analysis and communication between different entities of the software, and we can on the go change many things while the solution is in progress. It has advanced meshing and solver capabilities, starting from error diagnostic, manipulation of surface primitives, defeaturing for carrying out surface preparations. It also has surface wrapping technology, which makes it very easy to mesh. It reduces surface preparation times by several order of magnitude. The CAD cleanup process is very fast in this particular software, and the meshing, the automated meshing provides a very quick path from CAD to CFD. Technologies for volume meshing involve polyhedral and trimmed hexahedral mesh ties. Polyhedral is one of the highlights of this particular software. And in terms of solvers, there are segregated and coupled implicit as well as explicit solvers. Physics, it involves lots of complex physics. It has capabilities to solve many physics related phenomenon like fluid dynamics, mechanical stress, fluid structure interaction, heat transfer, Eulerian multiphase, Lagrangian multiphase, chemical reactions, turbulence, and the list goes on. There is aeroacoustics. There are many more things that goes on in the software, battery simulations, etc. So in terms of physics, it has large amount of physics capabilities, the physics that can be solved using this particular software. Highlights of the CFD applications, there are some very good examples that are available from the CD Arabco website, which highlight the application of this software in very complex physics related phenomenons. The first among them I'm highlighting here is the CFD analysis of an Airbus A380 with engine and landing gear modeled. Also a helicopter modeling simulation where the mesh around the blades, the propeller is changing, or which means that the remaining grid surrounding the propeller can remain stationary, whereas the grid attached to the propeller is only moving. This is an example of the polyhedral mesh around the helicopter blade, which makes it very easy to mesh different complex geometries. This is an example of an automotive engine thermal simulation using STAR-CCM+, and underhood thermal simulation using STAR-CCM+. Internal ventilation and thermal simulation example is here, as you can see within a cabin. Component level thermal simulation inside a router is shown in this particular example using STAR-CCM+, as well as CPU cooling fan analysis carried out using STAR-CCM+. And lastly, pollutant dispersion simulation using STAR-CCM+. In this particular simulation, the pollutant dispersed from the factory are modeled for their pollution content as well as thermal modeling. So now, after getting introduced to the software, let us actually see what is the workflow involved when we use this software. This is a short 5 minutes demo which will show you how the software can be used, from starting from CAD import right to seeing the results. So we'll quickly see this video demo. So this is how the software graphic user interface looks like. You import a CAD model in order to start the simulation. You scale the model to the required scale. Currently I'm using I'm increasing the scale by 10 times. This is the model of a wind tunnel simulation around a car. So I'm using half the model of the car in order to take advantage of symmetry. Now I'm splitting the surfaces of the model, which is a box around a car, and I'm naming different surfaces like inlet, outlet, floor, top, the wheels of the car, the body of the car. After that, I'm actually generating I'm shifting the parts to the region so that I can define physics for the different parts. I can define along with the mesh, I can also make them meaningful from the physics point of view. Like I can assign velocities to the inlet. Now I'm defining different boundary types, like I'm clubbing parts, clubbing the surfaces into wall boundary condition, inlet boundary condition, outlet boundary condition. I'm basically defining a CFD problem within STAR-CCM here. After that, what I do is I use the automated meshing tool in order to generate mesh for this particular problem. I'm selecting different meshing algorithms, and after that I'm defining mesh size, which is the local mesh size, as well as the growth of the mesh. I'm using a size of about 0.25 meters. And now I'm executing the mesher, which means it is automatically calculating the mesh and generating the mesh. In order to see the mesh, I'm creating a mesh scene, which is a mesh display. And this is how the mesh looks like, making it transparent around the car body. This is how the mesh looks like. After that, I have to define the problem from physics point of view. I have to give select different solvers, select different models, that is flow model, turbulent model, thermal or material model. That way I define different models for the problem. I also need to define what is the boundary condition, that is what is the value of the velocity at the inlet. So I define the velocity of the inlet around 15 meter per second. And now I'm defining wall boundary conditions to different wall domains of the surfaces. And after that, I'm creating a scene. A scene means I'm creating a post-processing entity in order to display pressure as the simulation goes on. We have started the simulation, and you can see the simulation progress by seeing the residual plots. Simulation progress is, I have defined simulation for 300, but due to time limit, this demonstration has been shorted down, and we'll see directly the final picture after the solution completes. So this is how the solution looks like after 300 iterations. This is how the pressure development is there around the car body that we can see. So this was a demo showing the workflow, a short demo. Of course, if you are interested in much more details, there is a course that we have on STAR-CCM+, which will teach you how to carry out all these analysis. Going forward with the presentation, now before we end the webinar, I would like to give you brief information about our course, about our STAR-CCM+ course. Our aim is to impart best-in-class software-focused training on STAR-CCM+ using online training. And we aim to produce industry-ready STAR-CCM+ skilled CFD analyst. And what we will do within the course is not only teach the software, but we will also review and establish strong base in CFD theory and practical knowledge. The learning curve for any participant who takes part in this course, or who is interested in this course, anyone who is interested in CFD, this is a complete packaged online course for you. It will teach you fundamental knowledge of fluid dynamics and heat transfer. It will also provide training in fundamentals of CFD, that is a basic theoretical background in CFD. Then we will move to software training, first on meshing and CAD cleanup and CAD import. After that, on conducting CFD simulation using STAR-CCM+. Then we will teach how to analyze and extract different different results from the simulation, like different contours, plots, animations, and how to make sense of all the results. We'll also have a mini project at the end, which completes the entire learning curve of understanding what is CFD, applying CFD, using a software tool to do a mini project. So this is what our course consists of. The course details, it is a basic level course. It does not require any prerequisite. Only requirement is you have interest in CFD. The duration of the course is 6 weeks, including interactive training, workshops, mini projects and assignments. The recorded videos are about 16 to 20 hours of recorded lectures. What do you get out of this course? This course gives you course video access, interactive sessions with tutor, question answer sessions, on-demand demos and workshops, mini project, assignments, certification, and not just training. This course also provides free access to STAR-CCM+ software during the course duration, which means you can do hands-on practice. We will provide you software access. You can do various tutorials, workshops, assignments during the course, and actually get trained in the hands-on of the softwares. Like, you get to use the software in our course. This is part of the course fee itself. At the end of the course, you get the hard copies of the notes and slides shipped to your location. So the course content, the first lecture will consist of CFD Fundamentals, which will be introduction to CFD, CFD equations, solutions, and finite volume method. The second lecture will teach you how to install and how to start using STAR-CCM+ at your end, getting the software, installing the software, getting the license. The third lecture will be on the workflow, that it will give you overall feel of the STAR-CCM+ software, how to launch it, how to use the software, what is the graphic user interface, what is the model tree, basic structure, how to handle different files. The fourth lecture is on geometry modeling, which will teach you how to use 3D CAD model, create and import geometry within STAR-CCM+, repair geometry, clean up tools. It will teach how to export parts as well as display of geometry, how to display the geometry. It will teach you surface preparations and repair and manipulation, how to define simulation topology. Concept of geometry parts and regions will be clear to you, so that you can start importing different geometries within STAR-CCM+. The next lecture will be on meshing, which will be introduction to the meshing concept, part-based meshing, region-based meshing, application of surface meshers, surface wrappers, surface remeshers, generating volume mesh, polyhedral mesh, tetrahedral mesh, prism mesh, modification of mesh, how to edit and refine the mesh, as well as how to know the mesh quality. Then after that, STAR-CCM+ physics modeling is the next lecture, which will teach you how to define the problem from physics point of view, how to import different mesh for physics definition, carry out steady state, transient state simulation, define material properties, flow modeling, turbulent and as well as laminar modeling, thermal energy, that is carrying out conjugate heat transfer, defining different boundary conditions, how to use the energy modeling techniques, how to set up the solver preference, and how to actually carry out or conduct CFD simulation within the software. The last part, or the last lecture, is lecture 7, is actually on how to extract different type of results. As images shown here, you can extract different contours, different plots, different animations. So this particular course will teach you all those things. This particular lecture will teach you all those things. So in addition to lecture, what you get out of this course is there is additional content. You get to practice tutorials and workshops. You get on-demand live workshops with our tutor. A dedicated tutor will be assigned to you to clear all your doubts. You can ask him to set up online sessions, during which you can directly ask him or her the questions. Our tutor will take care of those questions. There will be question answer sessions, FAQ, mini project will be given at the end of the course in order to test how much you have gained confidence. If not, you will be given additional assignments, additional hands-on practice, additional training. So this is all the aspects that our course tries to teach. It tries to teach the fundamentals of fluid dynamics and thermal sciences, fundamentals of CFD, how to use the CFD software, how to generate mesh for industrial level problems using STAR-CCM+, and how to use the CFD in the design, how to make sense of the CFD results, how to make design decisions based on CFD results. Using the mini project, we try to teach all these aspects. So our suggestion or our motto is to instead of restricting yourself to classroom training based on a rigid syllabus, rigid schedule, our course tries to teach you CAE softwares or CAE technologies without any travel. You can go over the material any number of times, have interactive sessions with dedicated tutors. There are a library of tutorials prepared by our expert faculty, and this all comes in a cost-effective way, just using internet right at your desktop. These are the different courses that we offer currently. The latest among them is CFD modeling using STAR-CCM+. How, if you want to connect to us, or if you want to ask any doubts, or if you want to listen to the free material or read the free material that we provide, you can actually check us out on our LinkedIn page, on our Facebook page, Twitter, as well as on the blog. So our blog provides a lot of free material, the blogs that we post. So this is the way to connect us, but the best way to connect us is actually just email us at info@learncx.com. So the summary of this webinar is that I tried to introduce you to the idea of CFD, the CFD process flow, and an extensive introduction was given to the STAR-CCM+ software. Also, brief information was given on the capabilities of STAR-CCM+, and the highlights of our latest course, that is CFD modeling using STAR-CCM+, was provided to you. And at the end, I also gave you demonstration of conducting CFD or the workflow through the STAR-CCM+ software, just to give you a glimpse of what the software is or how the software looks like. If you have any questions, you can put the questions in the message window right now, and I'll try to answer your questions here. If some of the questions are left unanswered, or if you have more questions later on, the best way to reach us is to email us at info@learncx.com, and our tutors will get back to you. Whether it's a very simple question which does not require any fee, you can just ask this, or if you want to get trained in any of the software, there are courses that you can ask for us. So we don't hesitate to email us regarding any of your queries, and we'll try to get back to you. So thank you for attending this particular webinar, and I'll try to answer different type of questions that you may have here, and if time permits, I try to answer all the questions, or if not, you can always email us at info@learncx.com. So thank you for attending this session. I'm now stopping the sharing of the slides, and I'll try to answer your questions in the chat box. Thank you.